Good morning. Good morning to students, LBS College. Dr. Radhika Nair, madam, can you hear me? Audio is okay, madam?
Yes, sir, it's clear. Audio is clear.
We are talking about a 1-hour session where we are going to share our thoughts on precautions at plant, that is Readymix plant and site. So, Kaushika, I'm from QCrete Readymix Private Limited, QCrete Readymix company and QCrete Private Limited. We are starting to introduce a very novel, innovative additive for concrete, which can reduce cement content or cementitious content. I'll just start talking about what precautions we have to take both plant, that is Readymix plant, and what we have to do inside. And some of the thoughts what we express in this program are sometimes may be repetitive. That is only to reinforce some information which are very important. Once again, before I start this program, I thank profusely Dr. Radhika Nair from LBS College of Engineering, Kasaragod, for inviting me to this lecture. And I believe students will benefit from this program. So we do some mistakes in water cement ratio. That mistakes what we do with water cement ratio and what we take with water cement ratio. I'm going to focus on this for quite some time, and considerable time we'll spend on water cement ratio. What is water cement ratio? As civil engineering students, you all know that water cement ratio is water divided by cement. For example, you have 180 liters of water in a concrete mix that you divide by the cement content or cementitious content. That is, say, for example, so it will be 180 divided by 360 kgs is equal to 0.5 is the water cement ratio. Now, what is the importance of this 0.5 or water cement ratio is what we are going to talk now. Earlier, it was only considered as water divided by cement, that is OPC, ordinary Portland cement. In other countries like US, it is also called as ASTM-C type 1 cement. Now, with the advent of other materials like pozzolanic materials, the water cement ratio is redefined as water to cementitious ratio. That is, if you have, for example, 180 liters of water in your mix and some amount of GGBS and some amount of OPC, then we have water divided by total cementitious material, including pozzolanic materials. The pozzolanic materials can be GGBS, fly ash, silica fume, metacrylene, microsilica, whatever it is. Nowadays it's called as water to cementitious ratio. Now, water cement to strength all engineering properties of cement, all engineering properties of concrete, and we need to know another point. Curing is the process by which enough moisture is maintained in the body of concrete for proper hydration of cement. So, for example, you have done the concrete. You have to protect the concrete, keep the concrete cool in the initial stages and also continuously until 28 days, so that water what you have added be available for cement to undergo hydration. What is hydration? Hydration is the reaction between cement and water. So if the water has to mingle and react with cement put into the concrete, that has to be prevented from escaping into the atmosphere through evaporation. So that process by which you control the evaporation of water, quick escape of water, is called curing. Okay, so curing is done through polythene sheeting, by spreading polythene sheeting, or by ponding. Ponding is the most trusted and tested method. You make concrete slab and fill up water on the concrete slab when the concrete hardens actually. Again, coming back to our subject of water cement ratio, the cement hydration, that is reaction between water and cement, can take place if there is certain amount of water in the body of concrete. Scientists have found long back that you require about 0.22 to 0.27 as the water cement ratio. That means to say, if we have a 400 kg of cement or cementitious content in the mix, you should have 400 into 0.27. That is about 110 liters approximately. I'm talking about 110 liters of water is required in the body of concrete when we are making a concrete with 400 kgs. So, but what happens in reality? In reality, in the mixed designs, we have 160 liters. You refer to any mixed, it says a water content. I'm talking about free water content. The free water content is the water which is available for cement to undergo hydration. So this free water content, what we add into the body of concrete while mixing, will be ranging between 140 to 160, sometimes 180 liters of water. So what we require is 110 kgs of water for a 400 kg cement content, but we are adding about 160 or 180 liters. So there is excess available water. And what is this excess available water? This excess available water in the body of concrete is called as water of convenience. Means simply is added to the body of concrete during the mixing to make the concrete flowable, transportable. Water which is added to the body of concrete goes on evaporating actually. The evaporation bound by temperature, humidity, and wind velocity. So these three factors, if the temperature is more, the water evaporation is more. If the humidity is, water evaporation is less. If the wind velocity is more, water evaporation is more. So based on these three, evaporation is decided. So what happens if the water is evaporating? If the water is evaporating, it leaves behind small tubes or tunnels in the body of concrete, which are called as capillaries. So more the water you add into the body of concrete during manufacturing of concrete or mixing of concrete or making of concrete, you are giving an opportunity for more water to exist in the body of concrete in the initial stages, and you are giving an opportunity for that excess water to evaporate. And more the water, more the evaporation takes place, leaving behind more and more capillaries in the body of concrete. So more the capillaries means what happens? The concrete becomes full of voids, and hence there is an effect on strength, there is an effect on durability. So the capillaries take up space that should be filled with concrete. They act as transit system for water vapor, moisture migration. They act as conduits. These capillaries act as conduits for transporting sulfates, chlorides, carbon dioxide, and all other materials going to on the durability of concrete. So what we should do, we have to keep the capillary formation to minimum. Keep the capillary formation to minimum, keep the water cement ratio to a minimum. We have to add only adequate amount of water to the body of concrete. We should not add excess amount of water. Control the curing, cure as long as possible. In case of OPC mixes, the Indian code IS 456 says that you have to cure a minimum of say 7 to 10 days before deshittering. And in case of when you are using supplementary cementitious material, that is fly ash, GGBs, etc., you have to cure up to 14 days because the rate of gain of strength is lesser, lower. Use of WRA or HRWRA means you have to use a chemical admixture. Suddenly you cannot decrease from one mix to another mix water content. You need to use a chemical admixture to reduce the water content. So to make a durable concrete, better concrete capillaries, you need all the things together. You have to do A, B, C. So why do capillaries make concrete weak? Already because they take up space. Concrete. For example, you take steel. Steel is having a density of 7.85. The molecules are packed close. The opposite of it is, for example, you take cotton. The molecules are dispersed actually. Molecules are not held together. You have a lighter material on one side, that is cotton. On the other side, you have a very heavy material and a dense material. So obviously the strength of such a dense material will be more. So if you have concrete with a lot of pores material, you will have a lesser strength. That is why we say that strength of concrete is inversely proportional to water cement ratio. Coming back to the capillary pores, you have physical form. Capillaries are formed physically when the water is drained out due to evaporation, that is capillary pores, and gel pores are those pores which are arranged or happen when the hydration of cement with water takes place. That is, in the hydration products, in between the hydration products, you have these gel pores, and there are other kind of pores, the pores which happen in between the coarse aggregate and the cement sand matrix, that is mortar. When water evaporates, it cannot take a difficult route. It will take the path of least resistance. When the water, it cannot pierce a stone or aggregate, and it cannot go out piercing a stone. It takes an easy path. It will take a mortar route, and if this route aggregate, that is, if it is in the transition, this pore as a pore formed in the which interferes the bond strength actually. The bond strength will be reduced when a pore is formed at the transition which is existing as a bond between coarse aggregate to cement sand mortar. So these set of pores, capillary pores, gel pores, and pores at the transition zone define the integrity of concrete, or define the strength of concrete. Now the network of pores, their overall concentration, interconnectedness, diameters of pores, continuous network of pores determine permeability, which is very large factor in determining the durability of concrete. Now we need to understand these two curves. As civil engineers, practicing civil engineers, at any point of time in our life, whether you are in the production point of concrete or whether you are receiving the concrete, you need to two curves actually. So here on the left hand side, you have this curve which depicts the relationship between the strength of concrete and the water cement ratio. Here we can see as the water cement ratio goes on to the right hand side, that means as the water cement ratio increases, the strength decreases. Let us say here 0.4, The strength is 6000 psi. 6000 psi means 6000 into 0.07, that is about 42 MPa or 42 Newton per millimeter square. On the other hand, when you move this water cement ratio to the right hand side, edge of this graph, water cement ratio goes to 0.8 and the strength is 2000 psi, that is 0.07, that is 14 MPa. So from 40 MPa, the strength goes down to 14 MPa approximately when you are moving a water cement ratio 0.4. So this is the law of water cement ratio. The law of water cement ratio says the strength is completely governed by water cement ratio and strength is inversely proportional to water cement ratio. The other curve, which is this curve on the right hand side, it shows that as the water cement ratio is going up, the permeability is going up. The ability of absorption of liquid, ability of absorption of gases increases for the concrete as the water. So let us say 0.4, the permeability is least. Permeability is least. It is touching the x-axis. The permeability is, or the impermeability is maximum. On the other hand, when you are moving towards 0.8, the permeability is highest. The concrete becomes almost porous. If you pour the and collect the water at bottom. So who needs such a concrete? Nobody needs such a concrete with high water cement ratio. If you are making concrete with high water cement ratio, you are going to have a lowest strength and highest permeability, means the durability is tremendously affected. So we need to see here. We need to see here that it is produced at 40 MPa. If it reaches the site, we produce the concrete at 40 MPa at a water cement ratio of 0.4. When it reaches the site, it reaches your site, you have to receive the concrete. Here you go on adding water. Somebody goes on adding water. Why he will go on adding water? He may be crazy fellow or who doesn't understand what is he doing. He doesn't know the effect of water cement ratio, or just to make the concrete more fluid or finish the work faster, or for some other reason beyond comprehension, he will go on adding water. The person whom I am talking about may be labor or pump operator or anybody who is on site. If he goes on adding water, he is shifting the water cement ratio to the right hand side and hence deteriorating the concrete from M40 to M24. So our most important point and responsibility as a QC engineer or an engineer on site is never allow addition of water. You can, if you are doing like that, you are indirectly hampering the strength of concrete. If you are adding water on site, you are indirectly decreasing the waterproofness or impermeability of concrete, increasing the permeability of concrete. Once the permeability of concrete increases, you have all the gases like carbon, oxygen, water enters into the body of concrete and the durability of concrete reduces. The biggest enemy for reinforcement structure RCC is water and oxygen. When water and oxygen gets into the RCC, touches the reinforcement bar, corrosion takes place, and this corrosion, for example, you have a 1 mm steel bar, 1 mm thickness steel bar. It will swell. It will swell. The corrosion product will swell up to 4 to 6 times actually. That means a 1 mm attacked concrete, corrosion attacked will become 4 to 6 mm. Where is the space for 4 to 6 mm to be accommodated? There is no space in the concrete body, and then what happens is it pushes the aggregates, it tries to push the sand, cement, mortar, and cracks develop in the body of concrete. So it is very, very essential to know that you cannot increase the water cement ratio. Just so after understanding the water cement ratio law, can you after understanding water cement ratio law, why do we need high cements? For example, once we understood the water cement ratio law, we need to know that it is not the cement content, it is the water cement ratio which governs the strength. For example, if we go back here, there is no mention of cement content here. It is water cement ratio versus strength. So the water cement ratio law is very important, and we need to understand that it is not the cement content which is important, it is the water content and water cement ratio which is very, very important. So we have another one graph which shows the importance of water cement ratio, as told in the other graph. The water cement ratio goes on the right hand side, that is onto the right hand side, the strength decreases. Strength is independent of cement content for a given water cement ratio, and increasing cement content does not affect. So we need to know, as students of concrete technology, engineers who are using concrete, that strength is independent of cement content, and for a given water cement ratio, increase cement content, go on increasing the cement content. This is very, very important to know. Increasing cement content, on the other hand, may adversely affect durability and performance by increasing shrinkage, chloride ion penetration, permeability, and crackings. So I'm coming to the practical aspect here. Three mixes: 400, 380, and 350. Water cement ratio 0.38. Dear students, just I want to check which of these mixes will give the highest strength. The answer to this is all the mixes will give similar strength. Even when you have increased to 400 kgs or 350 kgs to 400 kgs, the strength will be similar because the strength is governed by water cement ratio. So irrespective of the cement content, if the water cement ratio is same, strength is same. You need to know that throughout our life, whenever we are using concrete in RCC structures, high-rise buildings, residential buildings, apartment complexes, commercial applications of concrete, wherever we are doing, water cement ratio is godly. It is like God for us, actually, as far as the concrete is concerned. And we need to remember that this is the most important governing factor as far as the strength and durability of concrete is concerned. So what is the precaution that in the mixes? For example, on site. So according to me, we should not go on prescribing. For example, you should not tell I want 400 kg of cement, 200 kg of water, and all these things. You should not prescribe. You should leave that matter to an engineer who is already well versed with concrete mix design, or you have to leave with who has already done a lot of mix designs, or you have to leave with the Readymix company who is already having data. And then the concrete supplier is responsible for supplying concrete in accordance with the prescribed requirements, conducting appropriate and sufficient quality control to demonstrate and document compliance. That is his responsibility. The design mixes, the other one precaution that you have to take is, if you are doing design mix, the responsibility of the performance of concrete lies with the designer. For example, if you are a structural engineer or you are designing concrete or you are designing anything, the performance completely depends upon your design. The performance is dependent on your design and the material concrete mix design. So this is a better way of dealing with concrete. Whenever you want a particular grade of concrete or a particular performance type of concrete, you need to use a proper mix design principle and procedure, and you can do the mix design based on the data available on the materials and the performance. If you have already done other trials under the direction of the owner, conducting quality assurance and reviewing quality assurance reports are both to ascertain the owner's behalf that the performance criteria have been met. The strength, pumpability, durability, all these things you can decide yourself and design yourself. These are called design mixes, and this is a precaution that you have to take. If you are taking the route of design mixes, you need to consider type of materials, different kind of materials available locally. You cannot bring material from long distance. Whatever is available at the nearest point, you need to take and design the best mixes. Performance, the designer has the control. Here, when you are doing a design mixes, the concrete technologist or the designer has the control. The precaution that you have to take, another precaution is prescribing the cement content. So we have already talked about the cement content. Cement content does not directly responsible for the strength of concrete, and therefore it is better not to prescribe the cement content. It is better not to prescribe the cement content, and because we have already seen the water cement ratio law, where the water cement ratio law says very clearly that water cement ratio law very clearly says that the strength of concrete, durability of concrete is inversely proportional to water cement ratio. So it is not the cement content. So do not prescribe the cement content. And why we should use OPC? It is a precaution that we need to see. It is a very important aspect. Why we should use lesser OPC? OPC is the largest binder material used in concrete worldwide. We all know that. They say that human beings use concrete maximum amount of next to water by human beings is concrete. OPC has inherent problems. More OPC, higher is the heat of hydration. So it is said that every 100 kgs of cement content you are increasing. For example, you are moving cement content from 350 kg per cubic meter to 450 kg per cubic meter. What happens is every 100 kgs, the heat generated will increase by 11 degrees to. So you are accumulating the heat in the initial stages. Once the concrete is placed in position in a structure, you are building up heat in the body of concrete. So what is the problem if the heat buildup takes place in the body of concrete? Too much heat buildup in the body of concrete leads to differential temperatures at core temperature to surface temperature. Core temperature is temperature at the center of concrete. For example, you have made a 1 meter height concrete. The center of the concrete is at about 500 centimeter, half a meter below the surface. The difference in temperature, the temperature is maximum at core, at the center, and minimum at the surface, because the surface temperature is influenced by atmospheric temperature. It will be cooler. If the difference exceeds 15 degrees, the temperature at core minus temperature at surface, if it crosses 14-15 degrees, cracks will develop in the body of concrete. Hence, it is going to cause disaster for concrete structures if we are using high amount of OPC content. So heat buildup has to be contained, lessened. How we can reduce the heat buildup? Heat buildup can be reduced in a body of concrete during the initial phases of concrete hydration process is taking place. At that point of time, it can be controlled by using ice flakes or cold water during the manufacturing of concrete, then use of supplementary cementitious material. So first point which we need to think here is OPC higher cement contents is deleterious or detrimental to the longevity of concrete as it produces thermal cracks. Then second point is no point in using more OPC as we are aware of the fact that water cement ratio governs both strength and durability. Cement is the only man-made material in concrete. We know that in any man-made material has a tendency to go back to its natural state. The natural state of cement is limestone because 60 to 70% of concrete cement comes from limestone, and it has a tendency to go back to its natural state. And cement is the only synthetic product in the body of concrete. Other than cement, natural products means you have coarse aggregate, that is 20 mm, 12 mm, and sand. All these are natural products. So these natural products are already natural products. They don't have a tendency to go further back to its natural state, but cement has a tendency to go back to its natural state, and the travel from its artificially synthetic state to natural state will be aided by external agencies like temperature, chloride, sulfate attack, chloride attack, carbonation, etc. So lesser the amount of OPC that you keep in the body of concrete, the durability will increase. There is not much tendency to go back to its natural state. You are containing that tendency by using lesser amount of cement. OPC production is accompanied by production of carbon. One of the biggest challenges for the cement companies. Every 1 ton of carbon dioxide, every 1 ton of cement produced gives into the atmosphere 0.8 to 0.9 ton of carbon dioxide. Each 1 ton of carbon dioxide produced by human beings occupies 156 cubic meters of space. So entire space we are spitting venom in the form of carbon, which are also a very single largest ingredient as referred to as a greenhouse gas. So it is said that 6% of the total carbon dioxide human produce every year is produced by cement companies. So we need to reduce the carbon dioxide production because carbon dioxide is classified as a greenhouse gas and responsible for heating up of this planet. And we see Antarctica melting, and then once the starts melting in big chunks, you can see sea levels rising, and coastal areas, it is said that if the same amount of carbon dioxide which is being produced throughout the world continues to be produced, then by 2040, 2050, it is expected that most of the coastal line, not only in India but other parts of the world, will be completely drowned due to the flooding, due to rising water levels throughout the world. So it is our responsibility as citizens of this world to contain the total amount of carbon dioxide generated through human activities, whether it is cement production or any other means. Optimized cement content mixes will have positive effect on durability and also makes concrete cleaner. So whenever you are moving as a civil engineer in a project site, you have to take care of this precaution. You are contributing significantly to the environment by telling to your project managers to use lesser amount of cement or lesser amount of this kind of material, so that you are making a greener concrete and you are contributing to the world. You have SCMs. What are SCMs? SCMs are pozzolanic materials. They have benefits environmentally, technically, and commercially. The environmental benefits we already talked about. If you don't use 1 ton of OPC, you are indirectly reducing the production of 0.8 to 0.9 tons of carbon dioxide. You are lessening the world by carbon dioxide production by 0.8 to 0.9 tons. This is the single largest contribution if you don't use OPC. So instead of OPC, you have other materials like fly ash, which comes from thermal power plant, GGBS, which comes from steel plant, microsilica, it comes from a ferro metal industry. Metakaolin is a product which is burnt China clay. China clay is burnt between 650 to 800 degrees to get metakaolin, which is a supplementary cementitious metal. And then we have rice husk ash, which is once the rice is extracted, the husk or the hull of the rice is burned. That is called as rice husk ash. It is also having pozzolanic properties. What are pozzolanic materials? Pozzolanic metals were first found in a village in Italy. The name of the village is called Pozzoli. Romans used these pozzolanic materials 2000 years ago. Romans mixed lime, some amount of lime and volcanic ash with seawater to make mortars, and you can see the Roman Colosseum, which is standing for last 2000 years. There are other structures across the world where they use such kind of mortars. You can, if you go to Golconda, Hyderabad, you have this mortar which is rock solid actually. They should have used such technologies long back actually. So SCMs, which are the expansion is supplementary cementitious metals, they themselves don't have the cementitious or cementing properties. For example, if you take fly ash, which is a byproduct of steel thermal power plant, if you add water and come and see next day, it will not become hard concrete. It doesn't give strength actually. Similarly, GGBs also. Only when they are used in presence of cement and water, they react and they participate in what is called a secondary hydration process and bring more stable, denser compounds into the body, and hence it gives a durable structure to the concrete. So supplementary cementitious metals are, as I said earlier, they have properties, they have materials, compounds like Al2O3, SiO2 and Fe2O3, but they cannot themselves be completely replacement for cement actually. They have to be used in conjunction with cement. They have to be used along with cement. So that is why they are called supplementary cementitious metals. They are also called as pozzolanic materials. They are also called as mineral admixtures. So what are the uses of SCMs? SCMs increase permeability, resistance to chloride, resistance to sulfates, resistance to carbonation, alkali silica reactivity, drain, shrinkage, creep. All the above properties are improved significantly or kept at the same levels. Reduced permeability, one of the most significant impact by supplementary cementitious material. R.N. Swami, professor, Sheffield University, through his experiment stated pore volume is decreased by 61% after 91 days, and the coefficient of permeability by 56% by addition of 50% GGBS. GGBS is made from grinding slag. Slag is a byproduct of blast furnace, that is steel plant. And this slag is ground to a certain fineness, 3000 meters square per kg, and then it becomes ground granulated blast furnace slag, that is GGBFS. Okay, when you use this at 50%, Professor Swami says that the permeability is reduced more than 50%, that is 56%. Chloride ion resistance to chlorides is significantly increased. This particular graph, I draw your attention as students of concrete technology, where, for example, you have made a concrete, and in this concrete, you go to a depth of 25 mm. when you have traveled to a depth of 25 mm, if you have used no OPC, if you have used no OPC, that is zero BFS, that is blast furnace slag, 0%. That means the amount of chloride available is 1.8% or 1.7%. But when you add about 40% of blast furnace slag, when you add about 40% of blast furnace slag, the soluble chloride goes up to 0.5% or 0.6% at a depth of 25 mm. And when you go for a depth of 25 mm, when you add about 60% of blast furnace slag, there is zero chlorides. Means by adding about 60% of GGBFS, the chlorides have not been able to enter at about 25 mm. There is no chlorides available. Means in marine atmosphere, the chlorides have chlorides have a big role in defining the durability of concrete. Chlorides have a big role in defining the durability of concrete. So lesser the chlorides, higher the durability. So it can be defined by increasing the amount of GGBS. Okay. Now, other precaution that you have to take is if you want to have a lowest permeability. If you have lower permeability, this represents permeability, that is as per tested by Den permeability. So it is about 16 mm to 14 mm Den permeability, and the RCPT value. This is RCPT value. RCPT value here defined by columns. The RCPT value is rapid chloride permeability test. Rapid chloride permeability test. The rapid chloride permeability test means when you are testing tubes or cylinders as per this ASTM C1202, that is how much chlorides are penetrated into the body of concrete is defined by RCPT value. When the Coulomb's value 380, 320 is lower than 500, the concrete is said to be excellent. Sulfate resistance, when you have 20% and 40% fly ash addition, you have excellent resistance to sulfates. This is general purpose cement. This is cement, the concrete with fly ash. Heat, we have already talked about heat. Heat is produced maximum in a general purpose cement, that is OPC cement. And if you are using a blended concrete, you have lesser amount of heat produced and durability. And then you have long-term strengths actually. We need to know the long-term strengths. The long-term strengths are excellent. When you are using SCMs, 7-day strengths will be lower, 3-day strengths will be lower, and we need to know after 28 days from here, it takes off in a bigger way, and the strength goes on increasing. The long-term strength gain is significant after 28 days against OPC. So when you are using a OPC plus PFA, that is OPC plus fly ash or OPC plus GGBS, you have very good long-term strengths actually, which is very, very welcome property for a customer. You can see here, we took cubes at 2001. You can have OPC 240 plus 100 we had in this mix, and then the 28-day strength is 37.84 and 365 days is 55. You have a significant jump between 28 days to 55. Similarly, other cube result, which is 240 plus OPC, 240 OPC, 100 PFA, it has moved from 28-day strength of 38 to in 150 days 57. So long-term strength after 28 days is very good. This is a very, very important point for customers. Again, results have been studied, and in Coimbatore we had, if you consider 28 days strength as 100%, there is a 40% jump between 28 days to 90 days when you are using supplementary cementitious material. I am listing out the benefits of SCMs. So, and what is the precaution that we have to take is we must use supplementary cementitious material, either fly ash or GGBS in all our concrete. That's what I want to tell you. Blending at Readymix concrete plant, the proportion should be left to the Readymix concrete company, concrete designer. Don't try to specify the percentage of fly ash or GGBS. It should be left to the concrete company or concrete designer. And they have data, they have done a lot of trials, and they have both long-term strengths, durability studies. All these things have been made, and hence you have a very good concrete that can be designed and that can be produced. Sticking to wrong slump requirements. This is another precaution that you have to take. Indian code says 100 plus or minus 25 mm. So if you stick to 100 plus or minus 20 mm, 5 mm, it is difficult to produce the concrete like that. And only earlier days, slump was regarded as a direct measure of water cement ratio. It is not like that. With the advent of a lot of new superplasticizers and admixtures, chemical admixtures, we have very good products which can give high slumps at low water cement ratios. So you cannot link directly the water cement ratio to slump actually. There are other codes like BACN 12350 code, which talks about range. For example, they don't specify the slump, they say class 3. If, for example, somebody wants 100 to 150 mm pumpable concrete, he will say S3, you supply S3 slump. And here, the maximum allowable deviation is 80 to 170. There is also another way of specifying the slump. You specify 50 to 90, the allowable value can be deviated by plus or minus 40 mm. So these are some of the ways of specifying the concrete, and this is one of the precautions that you have to take. Don't specify a wrong slump because it may become very difficult for you to place the concrete, transport the concrete. We need to study this one and then specify the concrete. Not checking the producer credentials. So one of the precautions that many people don't bother about is whether the Readymix company is having proper quality control team in place. Just don't go by the facility. The concrete plant may look beautiful, have some big advertisement they may be doing, but whether the quality control people are there, whether the company is supported by highly knowledgeable, educated, experienced people, that we need to check actually. A Readymix company has to have 3 controls: forward control, immediate control, retrospective control. Forward control is set of all activities that we need to take care before production of concrete. Immediate control is set of all activities that a Readymix concrete company does at the point of production, that is at the batching plant. Retrospective control is set of all activities a Readymix company does after production of the concrete. So this retrospective means afterwards, after production of concrete, what are the quality control measures that we do is said to be in the retrospective control. So a Readymix company is bound to do all these things that we need to check. This is the precaution for a buyer. The buyer has to check whether the Readymix company is doing forward control, whether the Readymix company is in charge of immediate control, whether the Readymix company is doing retrospective control. So what are the simple things? Just I want to check visual checks, testing of purchased material, whether there are certificates for supplied material, information from supplier is there. Inward material is weighed on a weighing scale, that is big weighing scales, and then purchase basis is availability, product quality, long-term relationship with the supplier, delivery, material costs, freight costs. So you cannot bring the material from long distance, you have to bring from the shortest distance available, and then quality control and support, how the vendor is supporting the Readymix company. All these things are important which we need to control. Prevention of contamination means there should not be contamination happening between the materials. Drainage of aggregate should take place. The materials have to be stored separately. For example, one silo for OPC53, one silo for GGBS, another silo probably for fly ash, things like that. Traceability of materials. For example, you have done concrete. The concrete completely produced has to have a traceability, means on that day what is the admixture used, what is the cement brand used, what is the aggregate used, means which supplier has supplied the aggregates on that day. All these things should be traceable from the finished good to inwards. So that is how it has to be done. Mix design is based on data, trials, understanding customer requirements, intended use of concrete method placement, offered to customers, validation of mix design, arrangement of mix design. All these things take place in the mix design section. Plant maintenance is very important. Transfer of weighing equipment, control flow, calibrated weighing scale. Calibration is very, very important in a ready-mix plant. It ensures that, let us say you have the exact mix design, what is fed into the batching plant computer, the same thing is going out or not. That is very important. That is how the calibration helps actually. Also, calibration has to be done timely, once in 3 months as per IS, but many other ready-mix companies do every month. So plant mixers, truck mixers have to be maintained well, blade condition has to be good, mixer power, maintenance, check for concrete buildup, there should not be buildup. All these precautions we have to take. Control is, as we said, what is done at the batching plant, slump measurement and moisture correction. Moisture correction is most important activity. So moisture is given by the laboratory. Check the moisture is checked on daily basis, at least 2 times on sand, on 3 times in a monsoon season, 2 times on regular normal seasons, where to find out whether the sand is having how much amount of water into the batch cabin. The same thing is done on coarse aggregate and 12 mm, 20 mm and 12 mm also. And observation, visual observation of slump, sampling of concrete, whether the concrete is bleeding, whether the concrete is cohesive, pumpable, water content is okay. All these things are checked as soon as the concrete is produced at the batching plant. Sampling certificate, sampling concrete at plant to be done randomly, measuring recording slump, measuring temperature at plant, keeping some sample for checking slump retention. All these things are done at batching plant. This is part of immediate control. Retrospective control, strength monitoring, sampling at site, remixing and casting as per standard, protecting tubes in fresh state till transfer to lab, curing at right temperature, crushing tubes and recording. All these are part of retrospective control. For example, you have done the mix design. How much 1 cubic meter what you have produced, is it really 1 cubic meter? That is that method of checking or ascertaining whether you have produced correct quantity of concrete is called yield check. It is defined in IS 1199. We can go through the standard and have a yield check actually. So we have a list of parameters to be checked, has to be provided by producer and consumer of ready-mix concrete, like concrete engineers on site, have to check all these things as per IS 4926 Annexure G. There is a checklist also where you need to check what are the checks to be taken that you have to take, that you have to check when you are in batching plant as well as site actually. So for example, materials as per IS 456 which can be checked in batching plant, material testing as per IS 4926 which has to be checked, steps at batching plant to prevent contamination, mixing should not take place, calibration at batching plant, maintenance of batching plant, calibration of lab equipments, checks at batching plant, checks on site. A lot of checks have to be taken. What is the slump at site? What is the temperature of concrete at site? Whether the concrete is bleeding, whether the concrete is segregating, all this need to be checked. Whether the yield is right, all these things have to be checked on site. So Dr. Nadika Rai, Doctor, hello.
Sir, hello. Yes, sir.
Can I continue, or is it should we stop, or can I continue for another 15-20 minutes, or is it okay if I stop, or what is it you want? Means should I
Yes, sir. I think you can continue up to 10
another?
minutes.
Yes.
Okay. Okay.
Okay. So we are speaking about what are the precautions to be taken at batching plant and site. Now, very important phase we are coming to last 10-15 minutes. We are going to speak on what mistakes happen on site. The sampling, every product in civil engineering. When you go to a civil engineer, when you become a civil engineer, when you go to site, each product has to be sampled. For example, bricks, you are dealing with bricks, there is a way of sampling. If you are dealing with tiles, there is a way of sampling. If you are taking aggregates, there is a way of sampling. Similarly, there is a defined procedure of sampling of concrete. Actually, we need to follow religiously this procedure. This is defined in IS 4926. After the truck mixer comes, the mixer has to be remixed, and then first 1/3 of concrete has to be left. 1/3 of the concrete has to be left onto the pump, or it has to be discharged. And then we need to take at intervals as the concrete is moving down the tube. We need to take samples at regular intervals for checking the slump and strength. BS 1881 has developed a very comprehensive testing procedure which says that first 1 meter cube of concrete has to be coming down the chute, and then when the concrete is flowing down the chute, a scoop or sampling scoop, we need to run at right angles, and then after leaving the first meter cube to go, then we have to take from next 1, 2, 3, 4 parts and leave the last concrete to go. So this is a procedure defined by BS 1881, which is a time-tested procedure worldwide. Same procedure is used except in India. India says 0.3 cubic meters you have to leave. Other places, BS and ASTM standards, they say first one part has to be left. ASTM C94, American standard says you have to leave the first 10% of the concrete to go into the structure, fall on the ground or onto the pump, and then after that you have to take the sample. Last 10% you should not take. So this is the way of taking the concrete sample. There is another way, alternative method, where just for checking the slump, you can release 0.3 cubic meters out down the chute, and then you can take the concrete sample. In the second method, you cannot take the cubes. You cannot make the cubes. In the first method, both slump and strength cubes can be cast. Actually, cubes can be cast and slump can be checked. This is why the standard method. Making cubes. What are the precautions to be taken? The cubes have to have a dimension of 150 mm by 150 mm by 150 mm. Each layer of concrete has to be compacted by 35 strokes, 35 layers, 35 strokes, 3 layers. And once we cast the cubes, it has to be covered with polythene sheet or wet Hessian cloth. Evaporation of water should not take place, and it has to be kept in cool place under shelter. And next day, the concrete, it has to be transported to central lab or laboratory, and it has to be cured at 27 plus or minus 2 degrees. Why it has to be cured at 27 plus or minus 2 degrees? It is the IS standard. IS standards very clearly says the water temperature has to be 27 plus or minus 2 degrees. So we use AC to cool the entire facility in summer, and in winter when the temperatures are low, we use heaters. Heaters are installed, and heaters heat the water to keep the temperature 27 plus or minus 2 degrees. Why? Somebody will ask this question. My structure is at 35 degrees. I'm in Hyderabad. The temperature, ambient temperature is 45 degrees. And we are curing at 27 plus or minus 2 degrees. Why it has to be done like this? Because this is a standard. This is a reference actually. So if you are purchasing any material, there is a standard procedure to be followed for finding the properties of the material. So as per Indian standard 27 plus or minus 2 degrees, we have to cure the concrete. This is the reference actually, this is the reference. So whether you are in Delhi, whether you are in Hyderabad, whether you are in Ooty, Cochin, whichever place you are in, the curing has to take place at 27 plus or minus 2 degrees. Many big companies unfortunately don't do this one. They will do whatever they want and then they complain about concrete quality. This is a very common thing that happens in India. We have to cure at 27 plus or minus 2 degrees. Otherwise, you have actually, as per law and as per morally and lawfully, you don't have right to question the quality of concrete supplied by others, or even if you have produced the concrete also, it may be giving different results because the IS code says you have to cure at 27 plus or minus 2 degrees. Now, precautions we need to take once we have the concrete, there should be sample has to be taken from truck mixer. After mixing the concrete, there should be some revolutions of truck, means concrete has to be, drum has to be turned at high revolution for 2 to 3 minutes, and then we need to take the concrete, remix, and then the sampling has to be done as defined in BS 1881 or at least as per IS 4926 as we discussed earlier. Remixing of sample, we have to remix the sample properly. Standard cube mode should be there. Oil full compaction has to be done. If you don't do compaction, then the strength will lose. We will have a lower strength. Every 1% uncompacted concrete will 5% loss in strength. And then curing cubes under standard conditions, we need to do observation of cube faults, how the cubes are crushed, we need to observe accurate measurement of dimension and weight, accurate measurement of density of strength of concrete that we need to check. So J.D. Devar and R. Anderson, two researchers from England, they made a lot of statistical analysis, compiling data from throughout the world. More than 5,000 samples. Each sample is equal to average of 3 cubes. They say that if the predicted actual average strength of cube is 100%, means this should be the average strength of concrete. It can go either way because of errors. If you don't take proper precautions, sampling error can be negative or positive. Failure to remix sample, if you don't mix the sample, it can be negative. Distorted cube molds can be negative or positive. Incomplete compaction, negative, almost 20% down results. Curing temperature outside can be positive or negative, but lack of continuous curing, if you don't cure properly, it can be down. Concrete can be, strength can be down by 35% actually. Faulty cube location, if the cube is not placed in the center of the machine properly below the plates, then it 20% and a very small positive effect. Faulty test machine can have a significant negative effect. So these things we need to observe actually. Instead of that one, if we just say the concrete is not good, if we don't test and the concrete properly, don't take precautions, all these precautions, then we'll be misjudging the concrete. We'll be thinking that the concrete is good concrete as bad or bad concrete as good. So in site, concrete should not be unloaded after 2 hours as per IS 4926. Only if you are adding a superplasticizer or under retarding admixture, or if the climate is very cold, then you can extend up to 3 hours. You cannot have delayed concrete used into the structure. There are people who use after 5 hours, 6 hours and all. Definitely the concrete will not give that much strength. It will not have the properties as it is designed and desired. We need to be very careful that we should not use concrete more than 2.5 hours after cement is mixed with water. That is, once the water comes into touch with cement, from that point you need to take 2 hours to maximum 3 hours, especially at high strength concrete. You need to pour the concrete as early as possible. We should not blame on admixture. There may be setting time delay because if the admixture dosage has gone more, segregation can happen. Segregation can happen because of wrong coarse aggregates, amount of water, bleeding can happen because of more amount of water, high slump can happen of water, low strength can happen primarily because of high water cement ratio. Cracks in concrete can occur because of quick evaporation of water in the plastic stage. It is concrete has a property to crack. Concrete cracks, and the cracks will be induced into the body of concrete because of temperature, humidity, and wind velocity. And the cracks occur because when the rate of evaporation is more than rate of bleeding. Actually, if the rate of evaporation is more than rate of bleeding, for example, it is said that if the rate of evaporation is more than 1 kg per meter square per hour, then cracks will occur in the body of concrete. The best method is that we need to start sprinkling, we need to start retamping. Wherever the cracks have occurred, we have to retamp and close the cracks when the concrete is in still fresh state. And otherwise, these cracks, even though don't disturb the integrity of structure, they will become conduits, they become passages for oxygen and water and other materials to enter into the body of concrete, and the deterioration of concrete and the durability of concrete durability of concrete will be questioned actually. Hence, cracks should be avoided. The only way of avoiding the cracks is early curing. As soon as the concrete is placed, you need to take pesticide sprayer, and in the pesticide sprayer, you start spraying the water on the body of concrete as soon as it is possible. That the time is probably 1 to 2 hours after placing the concrete, depending upon the atmospheric conditions. If the temperature is very high, like in Chennai for example, or when the temperature goes beyond 35-36 degrees, quick evaporation will be taking place. Then you need to spray this within 1-1.5 hours after placing the concrete. Even when the wind velocity is high, it takes away a lot of water from the surface, and it will lead to cracks. So these are the precautions that we need to take. We need to take care of inconsistencies. We need to check the ingredients: cement, GGBS, fly ash, sand, coarse aggregate, all have to be checked regularly. Otherwise, if we assume that the concrete is good, it will not be good. We need to be looking at all the ingredients regularly. That is the job of Readymix company. And as a concrete receiver, if you are receiving the concrete at the site, we need to be checking up whether the cement brand is same, whether there is a change in properties of aggregate. Most importantly, we need to also take precaution. The precaution that you have to take is understand what the customer wants. What is your client is interested in, whether industrial floor, whether he wants concrete for roof slab. Roof slab, when you are doing concrete, the concrete itself is not waterproof. You need to add a waterproofing compound or take some precautionary measures when you are doing a roof slab. When you are doing an industrial floor, the industrial a good grade of concrete with abrasion resistance. So those things we need to recognize. I am thankful to Dr. Radhika Nair for providing me this opportunity to speak to all of you. I'm thankful for QCrete Readymix India Private Limited and QCrete Private Limited for allowing me to have this webinar with all of you. You can send any question to me. You can ask questions right now. If you don't have time, you can send the questions through Dr. Radhika Nair to me, or you have my email ID and my number. Anytime you can contact. I'm thankful once again for your time, for coming and hearing this webinar. Thank you.
Thank you, sir. Thank you for readily accepting your invitation to deliver this talk. It was quite useful. We got to know lot. I mean, you provided a lot of details regarding water cement ratio, supplementary cementitious material. I mean, what are the precautions to be taken when you have ready mix concrete brought to site? So it was very useful. And from the on behalf of the Department of Civil Engineering, I would like to extend deep gratitude to you, sir. Thank you very much for such a wonderful talk.
Thank you. Thank you. Thank you.
Thank you, sir.
Thank you.